Good morning. Hi, everybody. Thanks for choosing to start off your conference with me. We're here this morning to talk about APIs and data, things that can be very useful in a sysadmin's life. This talk is foundational. I want it to be accessible to everyone, so there will be things I talk about that you already know. I promise to move fast and get to the interesting stuff. That being said, if you decide this talk is not for you, you can go ahead and leave. My feelings won't be hurt, and I heard Rich is talking down in Dean's One, and he has candy. So. Okay, so when I say interface, you probably think of these, where you connect to the network, or a keyboard, or where a graphics card connects to the heart of your computer. But really, these are interfaces too. They operate with rules and expectations. There's protocol. When you go to the airport or walk up to the counter to place your order, you know what to expect, as does the person on the other side. Here's another interface with rules. In this case, a human interacting with a computer. While this is an example of an attempt at a natural language interface, it still has fairly strict rules. And then came the mouse. While the graphical interface is designed to be easily understood and mimics physical objects, it still has rules, but they're designed to be flexible. So we've clarified what an interface is. Now let's get to one of the things we're here to talk about today, application programming interfaces. Applications call operating system or platform APIs draw windows, render fonts, and all manner of things, so programmers don't have to handle all of the details themselves and the user interface is consistent. APIs break down into two main categories, public and private. The definition's just like it sounds. Public APIs are meant to expose functionality of an OS or application, while private APIs are intended only for internal use by the developer. Public APIs are intended to be consistent and reliable. Private APIs can change at any time. There's some great tutorials on how to build your own app for Apple OSs using OS or platform APIs here, but that's not the kind of API we're here to talk about today. A web API is a great way to get information out of or cause action within any web-based app that has a public API. Freshdesk, Freshservice, Jira, ServiceNow, Zendesk, and pretty much every other web-based ticketing system has an API. In my shop, we're lucky enough to have separate management systems for Apple and Windows devices. We also have an integrated ticketing and inventory system in Freshservice. All of them have APIs of one sort or another. One type of web API is called SOAP. It stands for Simple Object Access Protocol. It uses XML heavily and is common in financial and other regulated fields. ODBC is an interface to databases. It's not HTTP based like SOAP, but it does work over the internet. Most databases are based on structured query language, or SQL. There are many different flavors, such as proprietary Microsoft SQL, MySQL, MariaDB, even SQLite all have ODBC drivers. ODBC even has drivers for things like Excel and CSV. REST is the kind of API I'll be focusing on in the examples here. I think it's the easiest to get your head around and the most common. It's based on HTTP, so most requests are GET, POST, PUT. Some are like patch or delete. We'll get into that. Postman is a website and a desktop app for discovering and working with APIs. They're in business to help teams test and implement their own APIs, but their free tier is great for testing out your own API calls without writing code yet. They have this collection of public REST APIs. They're great for practice, and some even have useful information. Here I've drilled down to a topic near and dear to everyone's heart. That looks just like a normal URL. And sure enough it is. But what else is going on in Postman? We can see the type of request we're making of the web server as a GET. Let's go ahead and send that request in Postman. Now that looks different. We didn't get all the HTML and CSS and ads and everything like a web page. Why not? Headers. The accept header tells the web server what type of response you want. Those of you that have configured a web server before or read email headers might recognize this as a MIME type. This example is JSON, which we'll get into in a minute. Changing the accept header will change the kind of response we get. Changing the accept header gave us the data in the format we're looking for because the API was capable of that kind of response. Besides the fact that we got the kind of response we were looking for, we also see the HTTP status code 200 OK to let us know the server was good with the request. How do we know what types of responses we can ask for? Documentation. By definition, public APIs are documented. The quality of that documentation varies widely, of course. But looking through the documentation for dad jokes, we can see other possibilities. Ooh, we can get topical. We use the API's search function to narrow down the results we're getting back. In this context, search is what is called an API endpoint. Question mark term equals is a parameter. Now, let's say you wanted to get the latest pizza jokes without going through Postman. Postman will show you how. Over there on the right, that's the international symbol for code. Let's play. Clicking that symbol pops out a new pane on the right that shows how to do the same API call using curl, a command line tool for interacting with web servers. Let's try it. That's great, but let's say I'm sorry. Yeah, let's go on. That's another blob of JSON, which thought I had notes on here, sorry. Okay, that's great, but let's say Python's more your thing. Postman will translate on the fly. Postman's great for many things. You can build your own collections of related API endpoints, test your calls, figure out the syntax by trial and error where the documentation is less than ideal. But we're going to move on now. Remember our API call that returned JSON? It looks pretty gnarly, doesn't it? JSON stands for JavaScript Object Notation. While it's associated with JavaScript, it is a very common format for throwing data around the interwebs, regardless of what language you're using. From either scripting or algebra, you're probably familiar with parentheses. Don't worry, it's far simpler than all this, but the same sorts of rules apply, and there's different symbols used to group different types of objects. Back to our rules, our protocol, our structure to the data. We have to use these kind of structures to unambiguously represent our data. If we put some new lines and tabs in that same string of data, it becomes far easier for us humans to understand. The computer doesn't care. This is still valid JSON, just easier to read. And of course, there's many tools to help with visualizing data and its structure. You deal with structured data all the time, probably don't think about it. You have a shopping list that's a pretty simple structure, but it's still a structure called a list. Item, 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 an arbitrary number of items. Here's something a little more Mac and Mini. This is a list too. Spreadsheets are a very common way to organize data. But we seldom use spreadsheets just for a list. You could think of this example as 3 lists, and it is, but it's also a table. A, thing about A, other thing about A, B, thing about B, other thing, so on. Now, spreadsheets are not databases, but they look enough like one that people often use them that way. In this example, we have a column serial number that's unique for each item. In a database, we'd call this the primary key to that table. Databases enforce that the primary key is unique. Spreadsheets don't. So now, how about the contacts in your phone? We have different types of information about each of our contacts, don't we? Sure, we could represent it this way. Nothing wrong with blank cells in our spreadsheet. It would be called fields in a database. Uh-oh. Now we have a problem. Your iPhone doesn't, but your spreadsheet sure does. Contacts can have multiple addresses. We could still represent that in a spreadsheet, just add more columns. But here it can be an arbitrary number of addresses. You can even have multiple addresses called home. The database answer to this problem is to create another table. But if you've been carrying a contacts list around for a while, you know you can end up with multiple contacts for the same individual, We need a way to associate this addresses with a particular contact card. It's very common to have an ID field that uniquely identifies a record or row in your data rather than counting on any other element of the row to be unique. You'll never see it in the user interface, but that's how the tables are tied together. Notice the address table has its own ID field because you can't count on any part of the address to be unique either. You could either be finding a contact, then searching the address table. That's normally how you'd accomplish this with an API. Or you could ask the database to do the combining for you in what's called a join. But that's as far as we're going to go down the database road for now, because there's a data structure you're far more likely to encounter in an API response. The dictionary. Not like this exactly, but you have a keyword and things about it. Let's have another look at that JSON example from earlier. This is a dictionary. Actually, JavaScript, somewhat unsurprisingly, calls it an object, but it's the same concept, key and value pairs. We have keys and values. But what about this one? This is actually a list of dictionaries within a dictionary. It's still a key-value pair with results as the key and the list as the value. The list just happens to be a list of dictionaries because there's more data than just the joke about each joke. Now a slightly more practical example back to our contacts list. It's a dictionary. Here's the key with dictionaries inside it. It's a list of dictionaries within a dictionary with, of course, another list within that. It's a wonderfully flexible structure. You'll notice the address ID and contact ID fields came along. Behind the scenes, there's still a database with tables. Back to the dad jokes for one more thing. You see the concept of pages of results. Either you or the API itself can specify the number of results to return at once. This is called pagination. When you get to dealing with hundreds or thousands of records in a response, it will be paginated. Different APIs have different strategies for accessing multiple pages of results. In the Dad Jokes API, it gives us a few different methods to know that there's multiple pages of results. For one, it says current page is 1 and next page is not 1. Another clue is it says limit of 20, and if we were to count the results, we'd find 20. Absent any other clues, that alone might be enough to cause you to check for more data. But if you scroll down to the bottom of the results, you'll see other useful information. We have a count of how many results meet the search criteria, and a count of how many pages you need to request to get all of that data. You can go either way with this one. Either keep requesting pages until you get to the total pages number, or until you have as many results as you expect. In the Dad Jokes, here's an example from the Jamf API. It tells us how many total results we should expect, and we just have to keep requesting pages until the number of results equals the total. Both the examples we looked at so far include the pagination information in the results. Some other APIs send the pagination data in the response headers. There's other things we'll need to use header information for, so let's look at one. Every web server will include headers in its response, not just APIs. But even curl pretties it up a bit. Python has a tremendously useful module called request that, like curl, is a Swiss Army knife for web transactions. And the data structure looks familiar, right? Yep. Another JSON object dictionary. Now, example.com is obviously a very simple web server. An API will often give you much more information in the headers. Now, there's a lot of information here. Much of it we'd really only care about for troubleshooting. But here we see some very useful information. When I made the initial request, I asked for 100 results per page. But we can see that there's 3,702 search results, so obviously we didn't get them all with the one request. There's two perfectly valid strategies here. We can take our original request and just keep incrementing the page number. But with this API, the headers actually tell you the exact request you need to get the next page of results, and you can keep sending requests as spelled out in the link header until there isn't one. So that's some strategies around pagination. As with any technology, there's usually more than one way to do things. But there's another piece of information in the headers we need to pay attention to. Anybody see it? The rate limit. The rate limit is usually per minute and is designed to prevent abuse of the server as well as balance the server load. Here you can see what the limit is, how much is left for this minute, and how much we just spent. We could definitely get the rest of the results we're looking for within this minute without exhausting our limit. But you have to be aware here. Are you the only one at your org that is using the API? Are there other higher priority tasks going on that you should respect? I have written some reports that make a lot of API calls, but they aren't time sensitive, so I'll throttle them as soon as the remaining gets below like 100, some large number like that, so that way the time sensitive tasks can keep processing and not get held up. Okay, now that we have a basic understanding of the way data looks as it's thrown around with APIs, let's see some real-world examples. Fresh Service is a ticketing and inventory system that we use in our shop. It has a robust API and good documentation. Here's the example for creating a ticket. We see that it's a post operation. Post is generally used when you're creating an object, in this case a ticket. The curl code example shows this as well. Here's the header that tells the API we expect JSON as a response. In this particular example, that's the only kind of response it knows, but the header is still expected to make sure everyone's on the same page. Here's the actual data we're sending, key value pairs. One of the values is a list. Since it's simply a list of emails, no further data is needed or useful, so it's simply a list, it's not a dictionary. Here's a part of the sample response. Much of it's just the data we sent to create the ticket, but there's useful information in the response. That is the ID of the ticket that was created. We can use that if we want to interact with the ticket further, for example, to assign it to an agent, or just to log the fact that we created a specific ticket using the API. Logging? Not this kind, the other one. So here's an example of a log file output from one of my automated jobs that verifies that computers that need to be encrypted remain so. It's crucial that you have logging whenever you start having scripts take action on your behalf. If you're going to have a script make changes to things, it needs to be logged so that you can go back and see what it did. So let's break this down. Having a title and a timestamp are good form. I highly recommend as you develop anything that will take action on your behalf that you build in options and start with the script explaining to you exactly what it's going to do and why before giving it the ability to take actions. In this case, the ability to actually create tickets came along much later in the process and remains optional because sometimes you just want to run the script and have it tell you what it would do when you're trying to figure out an edge case later on. When I have anything running on a scheduled basis, I find it very useful for it to email me the logs at the end of the run. Here, you could use Slack or your notification system of choice, both so that I know that it ran successfully and where it actually did. Here it's explaining to me why it's not acting on a few machines, because they're not done being set up yet. Here it's creating a ticket for a machine that appears to be out of compliance, and this is the ticket object. Since these tickets go in as requested by the end user, the text of the ticket has to be written with that audience in mind. There's a couple of ID numbers for the requester and the agent group. As we know by now, these are just lookups into another table, its primary key, as well as the ticket ID itself. We need that ticket ID because we're not done yet. We're going to add a private note to the ticket with instructions for the technician. This is just as important as the note to the requester. It tells the technician exactly why the system thinks the machine's not encrypted and how to rectify the problem. If the machine in question was a Mac, there'd be instructions for enabling File Vault and checking Monkey Report for the status. We know the ticket was created because we got a ticket object back. Here we got a 201 response from the server. There's kind of too many of them to remember. Things in the 200s are generally good, 4 and 500s generally bad, but there's an easy way to look up these response codes. Just go to your browser, enter http.cat/ and the response code you want to look up. So we know our note was created. Let's talk about these response codes for a minute. You do need to pay attention to them. If your API call was supposed to return data and it didn't, they can often tell you why. It can be as simple as the one that everybody remembers. This is hopefully just a typo in your API request. Where this one might mean you used a post where you should have used a put. Again, the documentation varies on whether it's clear on what method you should be using. Well, something like this could indicate a temporary problem with the server. Not something you can fix yourself, but important to know that if you were asking the API to do something, it, in fact, did not. You can't just assume that the commands you fired off were successful just because the syntax is correct and they worked before. This is a case where logging is essential, but alerting is useful too if this is something that isn't just being run ad hoc. Now this one is actually a documented part of API interactions. The web server is configured to only allow access to certain entities, and it doesn't trust you yet. There's information in the headers that let you know what kinds of proof the server will accept. It's looking for authentication. API authentication can take several forms. Basic auth can be just a username and password. The actual header looks like this. Curl gives a shortcut, and so does Python requests. Another popular method is called an API token. It ends up with a very similar looking header, but you generally substitute X for the password field. It's ever so slightly better than throwing username and password around in base 64, but not much. Hopefully you're at least using HTTPS. The other advantage is that you don't have actual user credentials in your code. API tokens can be revoked or changed in the event one gets compromised a lot easier than a user account. The bearer token is a temporary API key. You authenticate to the server or an identity provider and request a token which is intended to secure the rest of your session with the API here. No shortcuts here, you have to spell out the headers. You'd get this kind of token using OAuth or OIDC, but that's a little advanced for this talk. Now, an example of a different kind of API documentation. One particularly cool kind of API documentation is called Swagger. Jamf is by no means the only vendor with Swagger, just going for the easy example here. You go to the regular address for your web app and add /API on the end. You then authenticate to the server. It generates a bearer token. And you can pick an endpoint and try out actions live against your instance, your actual data. It'll give you a code example using curl. Which can be very helpful for figuring out the syntax and data that the endpoint expects, as well as the actual results. In this case, a list of all devices assigned to this MDM in Apple School or Business Manager. I use this data to compare against inventory and make a ticket to add the appropriate assignments to new assets. With the recently announced API for Apple School Manager, I should be able to fully automate this. Now let's look at another product some of you might use, Snipe-It. This is an amazing open source asset management tool with a REST API. Not only do they have great documentation and a Docker build that can have you literally up and running within 5 minutes, they also have API documentation that's very thorough and a fun little twist on Swagger. They give you access to an instance with demo data so you can practice your API skills with absolutely no setup at all. Besides listing the endpoints, they show what the various HTTP methods will do with that endpoint. And just like the Swagger example we were looking at, there's a code example and a try it button. And just like the Postman, we can pick from different languages for the code example. Quite a few different languages, in fact. Even Swift. Heck, they even give you the full open API specification so you can make your own Swagger docs. Don't worry, we're not going to unpack this here, but the format looks familiar, doesn't it? So I promised you that APIs could help you search in ways that the built-in search could not. While Snipe-It has pretty good reporting, I found something I don't believe you can do in the GUI. Snipe-It has a field called remote that you can use to designate remote employees. What if you needed to know what assets were assigned to remote employees? I'm going to use some example Python code that I wrote here. Please do not take my Python code as an example of how you should write Python. I am self-taught and most assuredly not holding it right. That being said, this is kind of how I structure the things that I write that work with APIs. First, I write a function to interact with a particular API endpoint that I haven't used before. In this case, we're reading all of the hardware records from Snipe-IT. While my code is not something to aspire to, I am handling both errors and pagination. I tell it how many responses I want at a time, but this API handles pagination differently than the other examples I've shown so far. I still tell it how many results to return at once, but this one doesn't keep track of pages. I have to set an offset where each request results start. I do a similar thing for users. Remember, don't copy my coding style. There's a lot of copy-paste between these two functions I just showed. You're smart people. You can do it better. My strategy has been to write a function for each thing that I want to accomplish that interacts directly with an endpoint. So we end up with a dictionary of dictionaries with a primary key of the user's ID. Looks pretty ugly, but we're used to this format by now, and Python handles it with aplomb. When I want to use that data, I write another Python script that imports the other one and calls my API functions. Now, what I've essentially done here is load up a representation of the users and hardware tables. Now I can match records in one of them with the other and filter it down. I know this is a lot to take in, so let's break it down. We're going to go through our hardware table. For each record in it, we're going to get the ID of who it's assigned to. And if we run that code, we end up with a list of the remote employees that have assets assigned and their asset tags. So we've looked at a few APIs and how to learn their capabilities. What are you actually going to do with them? Much of the power of APIs is in connecting data from multiple applications. If you're lucky enough to have separate management systems for Windows versus Mac OS, they'll still have some things in common, like state information of whether the firewall is enabled or last time the asset was provisioned. The information will be in different places, of course, but the information the management system has will be the most up-to-date and accurate. Information other than keys should generally not be replicated between systems or even tables. There should be one logical source of truth for each kind of information. You then use that source for reporting or taking action. Of course, with every rule, there's an exception. Let's say your ticketing system has an approvals process but no integration with your HR system. It's perfectly acceptable to sync the department and manager information from HR to the ticket system. That doesn't mean if someone wants to know everyone's manager that the ticket system is the place to look. You're just enabling functionality. So how do you tie these together? Serial number works well, but that's not a match. We can solve half the problem by just forcing both to uppercase. There's still a problem, though. Apple serial numbers can never contain a letter O. Now, part of this is a training issue, but people can still make mistakes. Your script can spot common ones and correct them. And now we have a match. This process is called normalizing your data. So now I'm going to describe some processes I've automated using APIs. Let's take another look at an example from earlier. Let's check that everything that should be is encrypted. Let's get a list of our assets. We have a business rule that states if a device is marked in inventory as unmanaged, it's not subject to encryption reporting because we have no way of verifying its status. These are generally assets that are never on the network. Likewise, we're not required to encrypt machines in a computer lab. Those have a different hostname convention. After getting rid of the records we don't need, we have just the machines that should be encrypted. Now, let's have our management systems tell us all they know. On the Windows side, I have a view into the database, which actually creates a table on the fly from the several different places that our Windows endpoint encryption process can record its status. For Macs, I'm querying an actual table in Monkey Report. Of course, there have to be exceptions to any rule, and in this case, we have a system in place for people to request exceptions to the policy and go through a multi-level approval. This was an in-house developed system before our ticketing system became able to handle the approval process. I had the developers of that system build me an API, which essentially just dumps the table of exceptions and allows me to process it. Now, of course, the exception system has to be different. Exceptions are requested based on host name. The serial number is nowhere in that system. Fortunately, the asset system knows what host name goes with each serial number once the data is properly normalized. We got one. Here's a machine that, according to everything we know, should be encrypted, and according to everything we know, is not. Our story could end here, but there's another couple things to check. Setting up a computer can take some time. We don't want to be making tickets if, say, a technician provisions a computer on Tuesday afternoon, doesn't enable encryption until Wednesday. In order to make it a little less of a hair trigger, I implemented what I call the delayed action file. The encryption check runs overnight, and it generates a report of all machines that are potentially out of compliance. If a machine was on the report yesterday, it increments the counter. If a computer's been on the report for 3 days, we generate a ticket for someone to investigate. This system's been working well for us for quite some time, but I was just getting started with automating processes. There are certain tasks that must be done when setting up a computer for a user. They might be accomplished differently depending on if it's Mac or Windows, but they can be described in general terms. Perfect use for a ticket template, right? Yes and no. Just because the tasks are listed in the description doesn't mean someone can't miss a step. Fortunately, our ticket system has the concept of tasks. Now that's a lot better. The ticket can't be resolved until all the tasks are complete. We have a log of who performed each task and when. But sometimes someone might think they completed a task, but it wasn't done correctly. By combining our data sources, we can verify that the tasks are completed correctly. This both maintains our compliance and reduces how often follow-up visits are needed. When the system sees that a task marked complete does not meet the criteria, it adds a technician note to the ticket and resets the task to open. Let's get a list of our open tickets. The ticket templates we're already using had some keywords in the title, and surplus setups that aren't all that different than new equipment. Automating an existing process works best when people can essentially do it the way that they're used to. In this case, I made it so they can either associate the asset, or they can put the asset tag or a serial number in the description, and the script will fill in the rest. Let's get everything that inventory knows about the asset. We can search by the asset tag number, since in this example that's what we're given. You can see it in that string. But what's with the other garbage around it? That's URL encoding, and an important part of how you form your API call. If it wasn't URL encoded, this is what it would look like. Makes more sense to us humans anyways. Also, apologies for the smart quotes that have slipped into this presentation here and there. You never, ever want a smart quote in code. I don't know what genius thought that a monospaced font needs to have smart quotes in it, but anyway, rant over. Inventory says that this asset is not assigned to a user. While I could have just pulled the requester information from the ticket, we felt that updates to assignments in inventory should be a conscious thing done by a human. So we add a note explaining what's wrong and reassign the ticket to the person that created it. I even made myself this nifty little dashboard so I can see at a glance the status of all our setup tickets. Remember the encryption verification system I mentioned earlier? I put in that delayed action mechanism partially for machines that are still being set up. Now that we're aware of all the machines being set up, we can automatically exclude them. So that's just a couple of examples of how I've used APIs to make our operation run more smoothly. Very thankful to my university and my college supporting me and coming here to talk to y'all, my management for helping me do work that fascinates me, and to y'all for listening. We got plenty of time left for questions if you have any. I'll raise your hand, I'll throw you the catch box so that the question goes on the recording.
So how are you automating your API calls? Because you're saying that you're running it on a schedule. What platform are you using for that?
I'm actually running that with a launch daemon on a Mac.
Awesome.
I have a whole list of tasks that run overnight, usually like 4:30, 5 o'clock in the morning, and then when I get up in the morning, I have a stack of emails that lets me know how everything went. And if I don't see them, then I know something's very wrong. Anybody else?
What's the most interesting thing you think you've ever automated with an API?
I've just been working through all of our processes for the life cycle of a machine, and right now I'm working on new equipment requests, and then we're going to get, we've already got the setup piece, and then I'm going to go into the decoms later. I have a daily task that runs we have a program where students can request a short-term loan or laptop, and I built that all the way from scratch. It combined an awareness of inventory and knowing the loaner pool and what machines were available and not. And then we needed approval from the student's department chair. Students were in the system as requesters. There's nothing tying them to a department. So I got access to LDAP, and in LDAP there's groups for students in a given major, and I was able to match that up with the departments and get an approval process that would send an email to the department chair for that particular student. it was very high demand during the pandemic, and it's still very much used today. Sorry, that was a rambling answer.
Hi, I'm pretty new to learning scripting in JSON and stuff like that, and I was wondering if you knew any good resources for learning how to dissect the JSON objects. Because you get, like you said, dictionaries inside of lists, inside dictionaries and things like that. And what's a good way of learning how to, like, this is showing us how to pull that JSON object a lot, but how to then work with it.
Well, for one thing, that that Postman tool that I showed early on will break down the JSON and prettify it for you, and it'll do all the indenting and stuff that kind of helps you to visualize the structure. There's also a ton of online JSON validators, and some of them have the quality of them varies, but some of them will try and explain things to you. Also, JSON is a standard, and I believe it's json.org. Anybody know? There's actually a website where it details exactly what every element in a JSON object is. Like that it explains that the brackets, the square brackets make a list and things like that.
But I was asking, like, or more like, how do I pull the list of things within this like 5-level deep object? Like, I always find it hard when I'm trying to learn using JQ and stuff like that on how to like reference and learn how to talk about the data that's there.
I get it. We got the one. Here you'll see I've got the I don't have a cursor now. I've got the hardware table that I pulled down, which was a JSON object, and within that I'm getting an ID, the asset ID, and within that asset I'm drilling down another level to get assigned to, and then that's actually another dictionary that within it has the ID of the person it's assigned to, and that's what I'm using to go over the requesters table and pull their name. So it's, the top level, and then each square bracket after that is another level deeper into the structure.
I'm also just learning how to get started with this. So do you have some examples of some well-documented or maybe easier to use APIs that are kind of commonly available that would be good to learn, so that when you get to the ones that maybe aren't as well designed, you're still able to kind of get things done?
Sure. I would highly recommend that Snipe IT. Both because they have the live data set that you can do API queries against, but also because that I mentioned the Docker build of it. I downloaded it, and within 5 minutes I had a running instance of Snipe IT and that I could load my own fake data into. I used that for that example. The online documentation for it is very good and covers whatever language you would want to use for it.
Okay.
Anyone else?
I don't get to throw this at anybody?
Hmm? Oh, come on. Too many animations. So please, please, please give me feedback. This is my first ever conference presentation, and I want to get better. Thank you all for listening.